Okay, guys, welcome to Cruise Class. Today we're going to look at algebraic statements and how we can carry out basic transposition or balancing of equations. Now, the first thing we need to understand is that an equation is any algebraic statement that has the equality sign between two sides, the left side and the right side. Cool? Now, equations are all about balance. If we add or subtract the same amount to one side, we have to do the same thing to the next side. Or rather, if we add or subtract an amount to one side, we have to do the same amount to the next side. So if we add 2, for example, to the left side, we have to add 2 to the right side as well in order to keep that balance, because once more, an equation is like a scale. It has to keep balance. Same thing for multiplication, same thing for division. If we divide the entire 5 plus x by 2, we have to divide the 7 by 2 as well, just to keep the balance. Imagine you have a scale and the left side of the scale has 5 pounds and the right side of the scale has another 5 pounds. The scale will be balanced because the same weight is on both sides of the scale. Now, if I were to add 2 pounds to the left side, it's going to tip the scale out of balance, because 2 pounds to the left side would now mean that you have 5 plus 2, which would be 7 pounds, right? While if you were to have 2 pounds added to the right side, the scale is now going to be balanced again. So what's going to happen is that the scale is a perfect example of how balanced an equation should be as well. But that's besides the point. Let's look at solving this basic algebraic equation. Now here we have 5 plus x equals 7. Now x is the unknown variable. This is what we're trying to find. We're trying to find out what x is. Now, obviously, just by looking here, we can tell that x is 2, right? 5 plus 2 will equal to 7, but let's work it out to see how we can actually get it. Now, the principle of balancing is, what we're going to do, we're going to try and get the unknown variable by itself. How can we get x by itself alone? We have to look what's beside it. We realize that positive 5 is beside it. So in order to get rid of the positive 5, we have to do something opposite to that. So we would have to minus 5 from the positive 5 in order for it to be cancelled. So when we minus 5 from this side, we have to minus 5 from this side as well in order for us to keep the equation balanced, as we spoke about earlier. Now, going on to this line, we can see that. So I minus 5 from 5 plus x, and I also minus 5 from 7. 5 minus 5 cancel, leave us with x alone. 7 minus 5 leave us with 2. So there we have x alone equals to 2. So x is equal to 2. So that is basic transposition. And we have another example we can go to. Give me a second. Now we have 3x equals 12. Same principle. We're trying to get x by itself. How can we get x by itself? We have to look what's beside it. 3 is beside it, but how is 3 associated with it? 3 is associated by multiplication. As you can see, 3x. This means 3 times x is equal to 12. So what can we do to get rid of the 3 that is being multiplied by the x? We have to do the opposite. We have to divide. So what we're going to do is divide 3x by 3, and we also have to divide 12 by 3 to keep the balance. So as we can see here, dividing 3x by 3, the 3 will cancel the 3, leave us with x, and 12 divided by 3 will leave us with 4. So therefore, x is equal to 4. So as you can see, these are just simple balancing equation examples, and that's how transposition is done. Now, every form of transposition has to follow these basic principles. It can only get longer after this, but not necessarily harder. So just stay tuned for more. Big up Cruise Class.